Hi guys, it's Miss Hill again, and we are here continuing our lessons on solving systems of equations. Today we're going to talk about solving systems algebraically using one of two methods. We're first going to talk about using the substitution method, and then we're going to talk about solving by elimination. So with substitution, we're going to do just that. We're going to substitute. But first we want to make sure that our equations are in terms of one of the variables. So that means we'll either solve for x or we're going to solve for y. But we want to have it solved for one of the variables. Then we're going to substitute our new equation into the other original equation. That's how we get the name substitution method. And then we're going to solve for the remaining variable. Remember, there should only be one variable left in that new equation. So we're going to substitute that answer back into one of the original equations and solve again, and now we'll have our answer as a point, and we can write it as that ordered pair xy. The other method that we're going to talk about is the elimination method, and we're going to pick one of the variables to eliminate. We want to get rid of one of those variables, and you can decide if you want to get rid of the x or the y first. It doesn't really matter. So you might need to multiply one or both of the equations by a certain number so that they'll have the same number in front but different signs. We want them to cancel out or eliminate. We want to get rid of one of those variables. Then we can add our equations together and solve. And once you've solved for that one variable, just like we did before, plug that answer back into one of the original equations and solve, and write your answer as that point or ordered pair xy. Alright, and then other things to keep in mind. Don't forget, we talked yesterday about those parallel lines or our systems that were the exact same line. So if we have the same line, we're going to have infinitely many solutions. Well, if we're solving algebraically, that means that both the variable and the number cancel out. Both sides of the equation will be true. So if both the variable and the number cancel out, that's infinitely many solutions. If only the variable cancels out, then that would be no solution. They're parallel. Okay, so just like before, infinitely many, they're going to be the same line, but both the number and the variable will cancel out, letting you know it's infinitely many solutions on that particular line. If only the variable cancels out, then there would be no solution because those are parallel lines. So we do want to keep that in mind as we work through today's problems. So we're going to look at one problem, solve it two different ways. The first way we're going to solve by using the substitution method. And with the substitution method, remember that's where we're going to get one of our equations in terms of one of the variables. So x or y, or in this case, a or b. If we have 3a minus 2b is equal to negative 3, and then we have 3a plus b is equal to 3. Well, I see that I have this b with the coefficient of 1, so that's the variable that I'm going to solve for. I'm going to get that by itself. So if I subtract the 3a from both sides, then I'm left with b is equal to negative 3a plus 3. So I've solved my equation for one variable. Now I'm going to substitute that. Since I know the value of b is equal to negative 3a plus 3, I'm going to plug that back into that first equation where I see the b. So I'm going to write that down here where I have some more room. I have 3a minus 2 times my b value, which is now negative 3a plus 3, and that's equal to negative 3. And now I'm going to use what I've been doing for years to solve equations. I see I need to use distributive property. So we have 3a and negative 2. Don't forget that negative out front of the 2 multiplies through. So negative 2 times negative 3a, that becomes plus 6a minus 6 is equal to negative 3. I'm going to combine like terms to give me 9a minus 6 equals negative 3. And then 9a is going to be equal to, let's fix that. When we add the 6 to both sides, 9a is equal to 3. So when we divide both sides by that 9, Kind of a squish there, but that's okay. So 3/9, that's going to simplify to 1/3. And now I'm going to take that a value of 1/3 and sub that back into either equation. It doesn't really matter which one. I'm going to bring it up here. But I'm going to use the second equation because we're solving for b. So 3a plus b is equal to 3. Well, we said a is equal to 1/3. So 3 times 1/3, that's going to give me 1, plus b is equal to 3. So that means that b is equal to 2. So now that I've found the value of each of those variables, then I can write my solution as 1/3, 2. And that would be the point where they intersect. All right, we're going to look at the same equation, but we're going to solve this time, instead of by substitution, we're going to solve by elimination. So 3h minus 2g is equal to -3, and I know sometimes the variables can be confusing, so if you want to change them to x and y, that's totally fine. I've had many students over the year do the same thing. So if we have 3x minus 2y is equal to -3, and you want to write this one as 3x plus y equals 3, totally fine, means the same thing, and you can just switch the variables back at the end if you need to use those variables for anything. But now for elimination, I'm looking to see what can cancel out. So if I have a positive 3x and a positive 3x, I need one positive, one negative. They're not different signs. I have a positive 2y a negative 2y, and then a positive y. So I have different signs, but I don't have the same coefficients. They won't cancel out. And then a -3 and a positive 3 at the very end. So those would cancel out, but I need a variable to cancel out. I need to get rid of or eliminate either the x or the y. So I'm going to, since I have my first terms here as positive 3x and positive 3x, I'm going to take this second equation and multiply everything by a -1. So if I have 3x minus 2y equals -3, and the second equation, when I multiply everything by that -1, that's going to give me -3x, and then minus a y, and then is equal to a -3. So now I can take our two equations here and combine them, and my positive 3x and -3x will eliminate. We have 0x left. There's nothing there. So we've eliminated the x. Now we can say our -2y minus y, that's going to give us a -3y. And then our -3 and -3 combine to give us -6. So now when I go to simplify, my -3y equals -6, dividing both sides by that -3, we find that y is going to be equal to 2, just like it was before. And now I'm going to take that y equals 2, and I'm going to plug it in. I know this is getting a little messy here, but bear with me. If we have 3x plus y equals 3 from our second equation, if we plug in that 2 for y is equal to 3. When we go to solve for x, we're going to have 3x is equal to 1, dividing both sides by 3. We still get x is equal to 1/3. So we have the same solution of 1/3, 2, which was the exact same thing that we got before using the substitution method. So you can see it doesn't matter which option you use to solve algebraically, you will come up with the same solution. So let's get some more practice here. And you're going to want to work these on your own paper to give you some more room, because as you can see from the first two examples, it takes a little bit of space to do these. Now with these, we can solve by using substitution or elimination. You can choose whichever one looks easiest for you. It doesn't matter to me as long as I can see your work. There will be some examples where I'm going to ask you to use a specific method, Others, I'll say using whichever method you choose. So looking at number 1, if I have 2x plus 4y equals 8, and then for the second equation I have 3x plus 6y equals 18. I don't have an equation that's already solved for a variable, so that's why I'm going to choose to use the elimination method. And this is an example where I'm actually going to have to multiply both equations by some number to eliminate one of my variables. I just need to figure out, do I want to get rid of the x or the y first? Well, seeing that I have 2x and 3x, I can get that to 6 very easily. I'm not working with larger numbers. I could choose to eliminate the y, but I'm going to be working with larger numbers. So I'm going to multiply everything in the first equation by 3 and everything in the second equation by 2, so that I now have, I'll bring it down here below, I have 6x plus 12y is equal to 24. Keep in mind everything in the equation gets multiplied by 3. Then we're going to do the same thing with our second equation, but I'm going to multiply it by a negative 2 so that I have a negative 6x when I multiply through, and my x's will eliminate. And then that's going to be a negative 12y. And then this will give us, it's going to be equal to a negative 36. So now I can go to combine and see that my x's eliminate. Well, so do my y's. So I'm left with nothing on that side of the equation. Over on the other side, 24 minus 36, that's going to leave me with negative 12. That statement is not true, so this is an example of when we would have no solution. These are lines that would be parallel to each other if we were to graph them. All right, another example, and this is one where you could easily use the elimination method, because we have x plus 2y equals 11, and then we have x minus 2y is equal to negative 1. So I see right away positive 2y, negative 2y. My y's are gone. So when I combine what's left, I have 2x is equal to 10, which means that x is equal to 5. So now that I have that, you can choose which equation you want to substitute it back into. I'm going to use the first equation and say that 5 is my x value plus 2 times y we need to figure out is equal to 11. So if 2y is equal to 6 when I subtract 5 from both sides, I can see that y is equal to 3. So now I have both x and y. I can write my solution as that ordered pair, 5, 3. And don't forget, it's always a good idea to do a quick check and see, does your solution make sense? Substitute those values back into both equations and see, does it work? So for our first equation, using x is 5 and y is 3, 5 plus 2 times 3, which is 6, so 5 plus 6, I do get 11, which we had on the other side. And then for the second equation, 5 minus 2 times 3, or 5 minus 6, is equal to negative 1, so it does check for both equations. I worked it correctly. All right, we have a few more examples here. Looking at number 3, this is an example of having two equations in standard form. So again, I'm going to choose to use this elimination method. I would not use a substitution method for this. It'd be too many steps. So looking at 5x plus 3y equals 9, and then 2x minus 4y equals 14. We could choose to eliminate x or y first. It doesn't really matter. But I see that with a positive 3y and a negative 4y, I'm just going to multiply the first equation by 4 and our second equation by 3. That way I'll have a positive 12y and then a negative 12y and eliminate the y's. So rewriting my equations, my first equation becomes 20x plus a 12y is equal to 36. My second equation becomes 6x minus 12y is equal to 3 times 14, which would give us 42. And then when we go to combine, we can see our y's eliminate, positive 12 and negative 12, they're gone. So we're left with 26x is going to be equal to 78. And when we divide both sides by 26, x will be equal to 3. And then I can substitute that 3 in for x to either equation. It doesn't matter which one. I'm going to use the second one. Mix it up this time. So we can say that 2 times our x value of 3 minus 4 times our y value that we need to figure out is 14. So 6 minus 4y is equal to 14. So negative 4y will be equal to, we're subtracting 6 from both sides. So it's going to be equal to 8. And then dividing both sides by negative 4, we'll get a negative 2 for y. So that means our solution for number 3, I'll write it up here. Let's see, we'll put it right here. So our solution for number 3 will be at 3, negative 2. And there's number 3. All right, let's work one using the substitution method, just because we haven't worked through very many of those. For number 4, this is an example of where you could easily use the substitution method, having 2x minus y equals 1. If we solve for y, we put it into slope-intercept form. Let's put it in slope-intercept form, solving for y, and then we can easily substitute. So when we switch it to slope-intercept form, we're going to have y equals 2x minus 1, which is what we're going to plug in to our second equation where we see y. So we're going to have 4x minus 2 times our y value, which is 2x minus 1, and that's going to be equal to 2. So we'll use our distributive property. Remember, keep that negative with the 2. So we're going to have 4x minus 4x plus 2 equals 2. And then when we go to combine like terms, well, 4x minus 4x, it's gone. We simply have 2 equals 2. Well, that is a true statement. So that means that we have infinitely many solutions. And you can choose which equation you want to write it as. But infinitely many solutions on, we'll go with the first equation, 2x minus y is equal to 1. So again, if the variable eliminates, and our numbers would as well, if we brought the 2 over to the other side, we'd have 0 equals 0, which is true. But 2 equals 2 is a true statement. So that means that we have the same line, so infinitely many solutions on 2x minus 1, or 2x minus y equals 1. All right, for the last two, I'm just going to tell you, you can get some extra practice from this and you can check your answers on Blackboard. Both of these I would use substitution. That would be my method of choice. And you should come up with the solutions of negative 2, 1. And then for number 6, your solution should be 7/4, negative 5/8. So check those and let me know if you have any questions. And you can feel free to email me or send me a message on Remind or ask in class tomorrow. And don't forget to be working on your homework. Check your answers on Blackboard, and I will see you in class.